Nature-inspired techniques in computing is one that aims to develop new computing techniques after getting ideas by observing how nature behaves in various situations to solve complex problems. One example is that there are many algorithms inspired by ant colonies that exhibit swarm intelligence and find optimal paths to food sources. So now we are talking about ant-based routing. Basically this uses a routing table rewarding the route successfully traversed by each ant. Ants are the symbol of the small control packet which flood the network. The idea of this algorithm is that the ants move in a straight line from nest to food source. At the next state, if there is an obstacle to avoid it, initially each ant chooses to left or right at random. Let us assume that the ants move at the same speed, depositing pheromone in the uniformly. However, the ants that by chance select to turn left will reach to the food source sooner, instead of the ants that turn right will follow a longer path. So ants will increasingly guided to move on the shortest path. The intensity of deposited pheromone is one of the most important factors for ants to find the shortest path. This is used in routing optimization in telecommunication networks, like the ad hoc networks and many other fields in computer science.
Another example that many people notice in the natural environment is the behavior of bird flocks and especially of the migratory birds. Basic models of flocking behavior are controlled by three simple rules. The first is that if the birds are too close, they move apart to avoid collisions. The second rule is that if the birds are apart, they move closer to remain with the other birds. And the third and last rule is that they move in the same direction as their neighbors. With these three simple rules, the flock moves in an extremely realistic way, creating complex motion and interaction that would be extremely hard to create otherwise. In flocking simulations, there isn't any central control. Each bird behaves separately from the others. In other words, each bird has to decide for itself which flocks to consider as its environment. Usually, environment is defined as a circle. The question now is how this information about the birds are useful for the solution of the problem in computing. The answer is that they are useful for avoiding congestions in wireless sensor networks, and this was the theme in Mr. Pavlos Antoniou, PhD. Congestion is the phenomenon that occurs when load injected into a network is near. The concept is that packets are like the different birds in the flock. The goal is that packets have to avoid the obstacles, the congestion region and dead zones, and after to flow towards a global attractor, in our case, the sink. The rules that each packet follows are repel from neighboring packets on nodes at close distance, attract to neighboring packets on nodes at medium distance, and each packet follows other toward the global attraction. These rules are the same with the previous rules for the birds.